Today you will be using the intermediate value theorem to find zeros and x values within a given interval. This is in Chapter 1, Section 4. The theorem states that if f, a function, is continuous on the closed interval from a to b, where a and b are some x values, and k is any number between f of a and f of b, so k is some y value between the two y values that are on the endpoints of your interval, then there are at least one number in C, so some x value in AB, such that f of C equals k. It's easier to understand with a picture. What they're saying, given some interval from A to B, notice the A and the B's are x's, so from here to here. And when you plug A into your function, you get this point up here. And when you plug B into your function, you get this y value here. So, given the function between these 2 points, there is some number in here that will give you a y value that is on the function. So, as long as it's continuous, and your y value and your x value fall within the y's and the x's that they give us, then you can find one or the other. This doesn't work if there is a gap or a hole or a vertical asymptote. You cannot use the intermediate value theorem if it is not a continuous function. So let's look at the first example. Verify that the intermediate value theorem applies to the indicated interval and find the value of C guaranteed by the theorem. Here's our function. Here's our A and our B. And then they want us to find the value of C, find the x value that we need, such that if we were to plug it into this interval, we would get a 6. In order to use the intermediate value theorem, you first have to make sure that you are allowed to. There are 2 rules. 1, is the function continuous? Now, they don't mean continuous everywhere. They just want to know, is the function continuous on this interval right here? Well, if you look right here, the only point of discontinuity is going to be this right here in the denominator, which means we have a discontinuity at x equals 1. 1, though, is outside the intervals because this is roughly 2.5. Since 1, the only point in which we have a discontinuity, is not inside the interval, then yes, our function is continuous, and we can proceed. 2, is the y value, when we plug our A in, less than the y value they want us to ask for, but then is 6 less than the y value when we plug our 4 in. So we need to find the 2 y values associated when we plug in these 2 x values. It's pretty simple. You just use your calculator. You plug 5 over 2 in for every single x, and you get roughly 5.8, which, yes, is less than 6. So good. When you plug the 4 in everywhere you see an x, you get roughly 6.7. which is greater than 6. So, since the y value we're looking for falls between the 2 endpoints that we were given, then yes, the intermediate value theorem applies. Woohoo! I feel like that should be more exciting. So it gets an exclamation point. So let's actually apply the intermediate value theorem. what it is saying is that there is some x value. We're looking for an x value that yields a y value of 6. So the y value, I'd like to point out, is 6. The y value is 6. When you look at the given function, where can I plug the 6 in? It's the y value, so I'm going to plug it in to the y value portion of the function. So 6 equals x squared plus x over x minus 1. I now am going to begin solving for x. Think of this as 6 over 1. I'm going to cross multiply and get x squared plus x equals 6x minus 6. I decided to distribute my 6 automatically, thus saving me some room on my paper. I am now going to bring everything over to one side. Get x squared minus 5x plus 6 equals 0. All I did is I moved all this over to that side. I can now factor. I get x minus 2, x minus 3 equals 0. So my two solutions are going to be x equals 2 and x equals 3. Recall though, we have an interval of 5 halves to 4. And 5 halves is roughly 2.5. So I cannot use x equals 2 because it's not within my given interval. So this must be my answer. When I plug 3 into the function, it's going to yield me an answer of 6. And there we go. That's the final answer. So we use the intermediate value theorem to prove that there was some x value within our given interval that would give us the y value that we wanted. Calculus is very much about proving that something works, not just doing the work to show, not just doing the problem. All right, another way to use the intermediate value theorem is to locate zeros of a function without graphing, or if they take your calculator away or something. So, given some interval from a to b, if f of a is a negative value and f of b is a positive value, there must be some value x equals c, so some value in between, where the y equals 0. And then it gives you all this other crazy stuff that I'm going to talk about in a minute. Well, here's what I mean. Let's draw a picture out to the side. Let's say we have some point right here. And it's going to be the point a, comma, f of a. We don't know exactly what it is, but it's negative. And then we have some point up here. We're going to call that b, comma, f of b. If these 2 points are connected in some manner, so a continuous curve and it's connected, then you know that it has to cross the x-axis somewhere. You don't know where, but somewhere at some x value, you're going to have a 0. We can use the intermediate value theorem to prove this. So let's look at the next example. Okay, we're going to use the intermediate value theorem and a calculator. Notice I did say use a calculator, so when they say that, please use your calculator, to approximate the 0 of the function in the interval from 0 to 1. We're going to approximate to 4 decimal places, which means you cannot stop until your interval has 4 decimal places in it. And here's the function we are going to be using. First, check to see if the intermediate value theorem applies. So we have to check that first. Remember, this means, is it continuous? It's a polynomial. There's no denominator, there's no radicals, there's no natural logs or anything like that. It's a simple polynomial. So yes, it is continuous. And then we need to see if we need to see if this is true. If our beginning point is negative and our ending point is positive, or vice versa. One has to be negative, one has to be positive in order for there to be a zero of the function. So we're going to plug in f of 0, because that's the beginning part of our interval, and we're also going to plug in f of 1, because that's the end part. When I plug this in, I find that I get negative 1, so that's negative. And when I plug this in, I find that I get 1, which is positive. So, since the beginning of our function is below the x-axis, but the end of our function is above the x-axis, there must be a 0 on the interval 0, 1. Now the fun part. We're going to call this step 1. So after, no, you know what? Let's call it step 2. Since we decided this will be our step 1, we had to check to make sure we could do it. So step 2, we're going to split the interval into 2 equal parts. So here we go. Watch me split the interval. I know. It was amazing. Be amazed. Here's 0. Here's 1. 2 equal parts. Okay, I know this is difficult. What's halfway between 0 and 1? Not a trick question. 1/2. Now, this was negative. This was positive. We need to now decide, is 0.5, is the point here, the y value, positive or negative? So we're going to check to see what the sign is at 0.5. So we need to know f of 0.5. Now, you can type this into your calculator over and over and over again, but here's what I recommend. Go to y equals and type the function into the very first place. Then go to your table. Well, go to table set. You need to make sure your ask is on, because we are going to ask it for very specific values. I want to know what the y value is when the x value is 0.5. Notice, all I have to do is hit it one time, and I see that at 0.5, my y value is negative. Gives me a negative 0.375. So that's negative. Which means the 0 cannot be between 0 and 0.5 because both of these are below the x-axis. So we're done with this portion. And here is our new interval. So here's what we're going to do. Step 3. We're going to continue repeating step 2 until we have reached the desired 4 decimal places. All right, so here's our new interval. 0.5, 1. We need the number that's halfway between 0.5 and 1. If you don't know how to do this, you could just add them together. 0.5 plus 1 and divided by 2. What is 0.5 plus 1 divided by 2? It is 0.75. We need to check the sign at 0.75. We need to know, is this value above or below the x-axis? So let's check it. Again, go to your table, plug in 0.75, hit enter, and you can see that at 0.75 we have a positive y value. So it is above the x-axis, so positive. That means the 0 cannot be on this portion of the interval. It's somewhere over here. So again, we're going to repeat step 2. We have our new interval from 0.5 to 0.75. We need to split it directly in half. Again, 0.5 plus 0.75 divided by 2. If you do that, we get 0.625. Again, we need to know what the y value is at this point. Is it positive? Is it negative? We don't know. So we plug that in. Again, go back to the calculator. Put 0.625 in your calculator and notice you get a negative y value. So it is negative here. Again, it gets very repetitive. That means that the 0 cannot be over here. It's somewhere over here because we got a negative number. So let's split our interval again. We have 0.625, 0.75. Find the number in the middle. Add these two up, divide by 2. So 0.625 plus 0.75 divided by 2. We get 0.6875. Find the sign at 0.6875. When I do it, when I plug it into the calculator, I get a positive. So it's positive here. We're almost done. So it's not over here. Here's our new interval. Notice we already have one decimal point at 4 decimal places. That's awesome. We just need one more. So let's make one more interval. Split it up. We've got 0.625, which is negative. We've got 0.6875, which is positive. We need the number in the middle. You add the two together. Divide by 2. You get 0.6563, roughly. We're going to round to 4 decimal places because that's what they wanted us to do. When I plug that into the calculator to find out if it's a positive or negative value, see what we get. 0.6563. Notice I got a negative. So it's a negative here, which means that our 0 is somewhere on the interval. So you would write on an AP test, you use words, thus the 0 is within, and then in interval notation, 0.6563 to 0.6875. And you have approximated the 0 within 4 decimal places. So you are really, really, really close. You could graph it and use the 0 function of your calculator to check. But if they ask you to prove it algebraically or to use the intermediate value theorem, this is what you would have to do. So well done. Good job. I'll see you tomorrow.